Solving systems by graphing. So a system of linear equations is a set of two or more linear equations containing two or more variables. So it should be in y equals mx plus b for it to be linear. And the solution of the system of linear equations with two variables is the ordered pair that satisfies each equation in the system. So if an ordered pair is a solution, it will make both of the equations true, meaning that the ordered pair that is given will satisfy and work when plugged in as the input and the output. What you'll notice to earn a graph is that the ordered pair that they give you is going to be that point of intersection. If they give you more than two linear equations, it still means it must satisfy all of the equations in the system. So if you're given a problem like identify the solutions of the system, tell whether the ordered pair is a solution of the given system. They'll give you an ordered pair and then they'll give you two equations. What you have to do is make a function table, the input-output table, and 4, 1 should work for both equations. So for this first one, we're going to take the first linear equation, x plus 2y equals 6. You're going to plug in 4 where the x is, so you're evaluating, and you're going to plug in the 1 where the y is. Then you do PEMDAS, so 2 times 1 is 2, and then plus 4 equals 6. So 6 equals 6 is true. Then you plug it in and you use it for the second equation. Again, you evaluate, so the 4 goes where the x is, and the 1 goes where the y is. 4 minus 1 is 3. 3 equals 3. Since this ordered pair made both of the equations true, then that means that this ordered pair, 4, 1, is the solution to this system. The second example here, they give you the equations and they want you to know if the ordered pair -1, 2 is the solution. So again, if it's the solution to the system, it must make both equations true and it will be the point of intersection if it was on a graph. So let's plug it in and evaluate. So the first function table is using the first equation. The second function table is using the second equation. Then you evaluate. Don't forget negative. When you evaluate, use your parentheses. So then you put in -1 where the x is. So it's 2 times -1 plus 5 times 2. Positive times a negative makes a negative. Positive times a positive makes a positive. Then following PEMDAS, you lost 2, but you found 10. You have 8. So it worked for this equation. It worked for the first linear equation. Now let's try it in the second one. So again, you use the ordered pair they gave you, the -1 and 2. So the -1 goes where the x is, and the 2 goes where the y is. Use PEMDAS. Positive times a negative makes a negative, so -3. 2 times 2 is 4. Lost 3, lost 4 makes -7. Well, the equation said it should equal 5. It does not equal 5. So while the ordered pair works for this linear equation, it did not work for this linear equation, which means it is not a point on this graph line. So that means that this ordered pair, -1, 2, is not a solution of the system because it must work for both, not just one. System of linear equations by graphing. Solve each system by graphing and check your answer. So all you'll be given is the system. When you're given the system, what you need to do is first graph it. So none of this would be known to you. So you put it into a t-table. And again, you only need 2 points to create a graph. So let's just say if you had a t-table, plug in 0 for x and then get your y. Plug in 1 for x, then get your y. Graph that line. Then do the same thing for the second one. Plug in 0 for your x, plot it. Plug in 1 for your x, plot it. Once you graph these two lines, you'll have a graph that looks like this. And if they intersect, that's the ordered pair. That should be the solution. So for this graph here, once I graphed it, I see they intersect at 1, -2. That means the solution for this graph, these systems should be 1, -2. But then it says check your answer. So how can you check your answer? You go back to what you had just learned with substitution and evaluating them. So then you say, okay, if I see that this is the intersection, that means that the ordered pair 1, -2 should work when plugged in here and should work when plugged in here. So let's check that. So let's check with the first one. You evaluate by plugging in 1 where the x is, and you should get -2 where your y is. You check it, yes you do. Then you check it for the second system. 1, -2. When you plug it in, it works. If you notice that your graph intersects, but these do not work, there must be an error somewhere. So now you know that the solution to these systems, when graphed, is at 1, -2. It is the point at which they intersect. If you're given equations like this before you graph them, what you might want to do is notice this here is in y equals mx plus b. Your slope is -1/2. That means down 1, right 2. And your y-intercept is at 1, so that's your start point. Your second linear equation right here, notice is not in proper format. So if that's confusing to you, I highly recommend you first put it into proper format. And how do you do that? Use inverse operation. So you know this x needs to move over to the right. So since it's positive x, it becomes minus x on the other side. So then this equation for here would be equivalent to y equals -x. Again, what would you do? Create t-tables. You need 2 points for each of them. Graph it. Once you graph it, find the intersection. And then once you have the intersection, check it by plugging them in to make sure that they are true. Then you're going to get some word problems. And with word problems, it's really important to write down your givens and to pick out what is important. So Bowl-O-Rama charges $2.50 per game plus $2 for a shoe rental, and Bowling Pins, which is a different place, charges $2 per game plus $4 for a shoe rental. Find out how many games the cost to bowl will be the same. The same, whenever you see this word, you're setting up the two equations equal to each other. They must be the same at both places. What is that cost? So not only do you have to figure out what their point at which they'll be the same, you then plug them that order pair in to figure out what the cost for each place would be. So let's make sense of the problem by figuring out our given. So the first thing you need to do is see it says Bowl-O-Rama, let's label it Bowl-O-Rama, is $2.50 per game. Per means multiply, so $2.50 per times, and your x, your variable, is going to be the amount of games you play, plus $2 for the shoe rental. That's the flat rate. That's going to be your y-intercept. Then Bowling Pins charges $2 per game plus $4 for a shoe rental. $2 per means multiply times the amount of games, so 2x plus 4. 4 is your y-intercept. All right, so now we have the two equations. Now again, to find the point of intersection, you can choose to graph them. So then once you graph them, what you'll see is that they will intersect at 4, 12. Well, at 4, 12, what does that mean? That means that this is the point at which they should be the same. So what is that cost for them to be the same? Well, to figure out that cost, you can plug this into one of the equations. So if I were to go ahead and plug it into the first system, you would plug in 4 where the x goes, and then 12 would be your y. So when you plug that in, $2.50 times 4 games plus $2 is equivalent to $12. If you plug it into the second one, you plug in the 4 where the x goes and 12 where the y goes. Notice that no matter which equation you use, they will end up being the same. So you would create a function kind of table for the first one, and you're going to plug in what is given to see if you actually get 0. So we know we should be getting 0 at the end. So what we do is we plug in the 5, 2, and so 2/5, where the x is, you plug in the 5, and then where the y is, you plug in the 2. And what we should see that when we solve this, you should get 0. So technically all whole numbers are over 1. So that means 2 times 5 is over 10 over 5 minus 2 equals 0. Then what you do is 10 divided by 5 is 2. So 2 minus 2 equals 0. 0 equals 0. So it worked for the first set. So now let's check with the next linear equation. 3x minus y equals 13. All right, well, let's plug in our ordered pair. So that means 3 times 5, because 5 is the x, minus 2 should get you 13. 3 times 5 is 15, minus 2, 13 equals 13. It worked. So since this ordered pair worked for both of the equations, then yes, 5, 2 is the solution of the given system. Okay, so now we're given another set and tell whether the ordered pair is a solution of the given system. So is -2, 2 going to be true and work for both of these equations? Is it that point of intersection? So what you do, again, is you just create your little function tables and you evaluate, which means you plug in. So for this one here, -2 goes where the x is, so it's -2 plus 3, and then the y, plug in the y. Again, coefficient next to a variable means multiply. So then you do PEMDAS. 3 times 2 is 6, plus -2. You had 6, you lost 2, you have 4. And again, you should notice that 4 equals 4. So it worked. On this one here, -x plus y equals 2. Now what you're going to do is plug in your ordered pairs again. Don't forget that negative that's right there is part of the equation, so then -2 goes inside when you plug in, plus 2, and then again it should equal 2. All right, well now you use PEMDAS. A negative and a negative becomes a positive, so it's 2 plus 2, and then 2 plus 2 is 4, and 2. That does not equal. So since this ordered pair worked for one of them here, but not the other, the answer for this is no. And that means no, -2, 2 is not the solution for this system. Given systems now and asked to solve it by graphing and to check your answer, what you do is you take those two equations that you're given and you create your function table so that you can get the ordered pairs. What I like to do, since I know they are linear, is go ahead and get the easiest point that you know, which is your y-intercept. And since this first one has no y-intercept at the end, we know that the y-intercept is 0. And if you have the ordered pair, then it's 0, 0. So that's the y-intercept for the first one. Then it says y equals x. So this time if I plug in 1 for x, well, if x equals y, then that means that it has to be 1. So 1, 1. Then I go to the next one and I say, okay, well, looking at the other system, the -2x minus 3, you can see that the y-intercept is at 0, -3. So I'm going to go ahead and plug that in, 0, -3. Let's just say you didn't know that. What you can do is you can plug it in, and then when you plug it in, you should notice that it works. So let's just see. So 2 times the 0 minus the 3 does get you the -3. Then you pick any other point. So you only need 2 points on a graph. So I'm going to go ahead and pick 1. And so if we plug in 1 in here, minus 3, let's see what we get. So negative 2 times 1 is negative 2. Negative 2 minus 3, lost 2, lost 3, you lost 5. So the other order pair would be at 1, negative 5. Once you have your 2 points, you can now go ahead and graph that. So once you graph these, of course, I'm working on a tablet, so on a piece of paper would be a lot easier to use a ruler. But what you should notice is that the point of intersection for these two should be at negative 1, negative 1. So right at the point of intersection, which is right here, and that is negative 1 comma negative 1, that should be the solution to the problem. How can you check if that's true? When you plug it in, when you plug it into each of the equations, so in other words, using negative 1 as the x, you should get negative 1 on the y. You do. If I put negative 1 in this t-table, and down here and I plug it in, negative 2 times negative 1 minus 3 should get me the negative 1. Let's see if negative 2 times negative 1, a negative times a negative makes a positive. So that would be 2 minus 3, which is negative 1. So since negative 1 works for both of these, you have just proven and checked your answer to make sure that negative 1 is the solution to the system.